Okay, we're ready to start the next section. This section's on polynomial functions. The first section is from a book. It's section 2.2 is on graphing polynomial functions. First, when you look at the graph of a polynomial function, it's continuous and has no sharp corners. So continuous means there's no breaks in it. There's no gaps. Continuity is a thing that you'll talk a lot about in the beginning of calculus. So continuous just means, there's no breaks in it anywhere. So there's no gap, no vertical asymptotes, anything like that. Basically, if you can draw it without picking up your pencil, it's continuous. No sharp corners means everything is smooth, so you can't have anything that looks like that. That's a sharp corner. Even that is a sharp corner. So no sharp corners. Now, when you're graphing, you want to look for some hints because you're not going to be able to graph the whole thing, and they're not uniform like a parabola is or anything. So one of the things you do is the leading coefficient test. Leading coefficient tells you what the two ends are like. Like this one, the first one I drew there, the left end is down, the right end is up. That'd be something that the leading coefficient test would tell you. What you do is you look at two things, the degree of the polynomial, and all you care about is it odd or even, and the sign of the leading coefficient, whether it's positive or negative. So if it's odd degree and positive leading coefficient, so I say the degree was 3 and the leading coefficient is positive, then it's down on the left, up on the right. And I usually write that like this, down on the left, up on the right. If it's even, the degree is even, so if the degree is 4 and that leading coefficient is positive, then it's up on the left and up on the right. Anytime it's even, both ends go the same direction. So even and positive means up on the left, up on the right. Now if it's odd, notice the odd one, they go in opposite directions. So if it's odd and negative, well now it's up on the left, down on the right. I always think of these as going downhill. If it's odd and negative, it ends up being downhill. If it's even and negative, again, if it's even, both ends go the same. If it's negative, that means they're both down. Think of what we did with quadratics with the parabolas. Remember, if A was negative, it opened down. So that would be even and negative, both ends down. Even and positive would be if A was positive. Remember, it opened up, that would be here. Like if we looked at this one here, since it's opposite direction, we know this one is odd. And because it ends up uphill, this one is odd and positive. So that'll help us get started with a graph. So like if I gave you this and say, okay, what is the end behavior? I didn't mention that thing before. This is called end behavior. So notice this one is even because the degree is 4. And it's positive because the leading coefficient is 1. So even and positive means both ends are going up. So that could be like this one is to the 4th, so maybe it looks up something like this. That would be a typical one for something that's degree is 4. Notice both ends are up. This next one, notice the degree is 5, so it's odd, and the leading coefficient is negative. Well, odd and negative means on the left we're going up and on the right we're going down. So this one might look something like this, maybe. Left end is up, right end is down. So that gives you a starting place there. Then one of the next things you want to look at is a 0. A 0 is where it crosses the x-axis. If you can factor it, if you set the factor equal to 0, then that is one of the zeros, obviously. We've talked about that before. It's the x-intercept is the 0. So it's where y equals 0. To find that, if you can factor it, as we've done before, you set the factors equal to 0. And that'll give you those x-intercepts, those zeros. Now, sometimes it'll be a factor more than once. That's called multiplicity. So like if I had one, let's say I had x minus 2 cubed. Well, if we set that equal to 0, x minus 2 equals 0, x equals 2 is one of the zeros. Because it's to the third power, that means it's multiplicity 3. So that's how we would write. The 0 is 2 with multiplicity 3. That tells you something about the shape of a graph. If the multiplicity is odd, the graph swerves as it passes through the 0. Think about an x cubed graph. X cubed graph, remember how it comes up, and if it's 0, it kind of swerves through there? That's what I mean by it swerves. So anytime it's odd, it swerves as it passes through. If it's even, then it doesn't go through the 0, it bounces off the 0. So if a 0 is even, it'd be like if you had a parabola that had a 0 right there. Maybe it looks like this. So it comes down and touches that 0 and bounces off. That's what I mean by that. So that's another thing. If you not have your zeros, if it has an odd multiplicity, it just passes through. The bigger that is, the more it swerves over. If it's even, it doesn't pass through there, it bounces off. So if you're getting ready to graph a polynomial function, first thing you do is check the end behavior, like we talked about in the beginning. Then find the zeros and their multiplicity, put those on your graph. Then, to see what's happening between the zeros, pick an x value between the zeros and plug it in to see how high or low it goes. Now, I also mentioned the intermediate value theorem. This is something that's used in calculus all the time. There will be a question on the AP Calc test that you take that involves you saying it's because of the intermediate value theorem. To me, the intermediate value theorem is logic. For example, here, if one y value is negative and another is positive, there must be a 0 between them because of continuity. That means, let's say if I graph, let's say I find a point here where y is negative. If I find a point here on the graph where y is positive. Now again, it has to be continuous. Remember, continuous, you draw it without picking up your pencil. Well, if I go from this point to this point and it's continuous, don't I have to cross the x-axis? So it doesn't mean there has to be a 0 right there. That's the intermediate value theorem. It has different applications, but that's probably the most basic one. If one value is positive and another value is negative, there has to be a 0 in between them. Because if it's continuous, it has to cross the x-axis. So let's go down here to graph this one. So if I want to graph, now first you check the end behavior. Now this one, notice there's x's in all these. If I factor out an x, looks like that. Now if we look at the beginning, this is odd, and the leading coefficient is positive. So that means on the left it's down and on the right it's up. So that tells us something about our graph. Now, here I started factoring it, so I saw that there was a common factor of x, so I factored that out. Now factor the rest of this. Well, if I factor that, that'd be x minus 2 and x plus 1, and set that equal to 0. Well, now if I set each of those equal to 0, I get x equals 0, x equals 2, and x equals 1. So let's see what we have for our graph. So we have a 0 at 0. We have 1 at, I'm sorry, that should have been negative 1. Sorry, I didn't read my own writing there. So it has a 0 at 2 and 1 at negative 1. We also know because it's odd and positive, on the left it's down, so here it's going to go down. On the right it's up, so after this point it's going up. So we know that. Now in between, like here, these are only 1 apart. So logic says this graph is not going to go very high. So I don't need to worry. I'll just make it a real shallow up. Sorry. So I put my zeros at 0, at 2, at negative 1. Again, on the left, since it's odd and positive, it's going down. So from this, and I know I'm going to go, after it goes through, it's going to go down. It's up on the right. So from this, and I'm going up. Now again, these two are only 1 space apart. Don't worry about that interval. You can't go very high in between, so I'm just going to go up a little ways. Now between these two, it's 2 spaces. We'd like to know how low it goes there. So plug 1 into the equation. If I plug 1 in there, I'm going to get 1 cubed minus 1 squared minus 2 times 1. So that looks like negative 2. So the point 1, negative 2, that tells me how low it goes. Anytime this gap is more than one space, you need to plug in a point somewhere in the middle or sort of in the middle, figure out how low it goes. So that would be a rough graph of that graph. This next one. First, its degree is 4, so it's even. The leading coefficient is positive 3, so it's positive. So even and positive means both ends are up. Now we try to factor that. Well, it looks like I can take an x cubed out. So that'd be 3x minus 4 left. Set those equal to 0. Here we get x equals 0. Now here, notice this is x cubed. That means this has a multiplicity of 3. Whatever the exponent is on a factor, that's its multiplicity. If I set this one equal to 0, I get x equals 4/3. Well, now let's graph that. So we have a 0 at, we have a 0 at 0, and we have 1 at 4/3, so somewhere in here. We know both ends are going up. Now notice here our multiplicity is 3. Remember we said if it's odd, it swerves. So here, this is this multiplicity is 3, so as it goes through here, we're up, so it's coming from up. We're going to swerve over there when that multiplicity is 3 instead of passing straight through. Then we're going to go down. If we want to know how low, this is a pretty tight space. We probably wouldn't have to find it, but let's plug in 1 anyway. If we plug 1 in there for x, I'll have 3 times 1 to the 4th is 3, minus 4 times 1 cubed is 4 is negative 1. So here at 1, we know it goes to negative 1. So it's going to come down here like this and then back up. And there's the graph. Or this third one. It's even because the degree is 4. It's got a leading coefficient of negative 2, so it's negative. Even and negative means both ends are down. Then set it equal to 0 and factor it. Looks like I can take out a negative 2x squared out of each one of those. If I take that out, I'll be left with x squared minus 1. Well, this will factor. That'd be x minus 1 and x plus 1, the difference of two squares, factors like that. So if I set each of those equal to 0, if I set this one equal to 0, I get x equals 0. And since it's squared, it has multiplicity 2. Here, x minus 1 equals 0, I get x equals 1. X plus 1 equals 0, I get x equals negative 1. So those are our zeros. Now if we graph that, we have a 0 at 0. We have 1 at 1. And we have 1 at negative 1. We know at the left it's down, so we're coming from down. We know it's going to come back up through here. Now this one has multiplicity 2. Remember, that means it's bouncing off, so it's going to turn over. Here there's only one space, so we know it's not going to go very high. It's going to hit that point and bounce off and go right back up, and now it's going to pass through 1 and end up down. So both ends are down. We have our 3 zeros, and this one had an even multiplicity, so it bounced off. All right, so that's if you're given the equation. Now, here's kind of the opposite direction. What if I tell you something about the function? Can you come up with the function for it? Well, here it has a 0 at negative 1. Now, what you want to do is to turn those in the factors. You always take x minus whatever the 0 is. So that's how you get a factor. You take x minus the 0. So here, if my function, a 0 at negative 1, well, if I take x minus a negative 1, that'll be x plus 1. Multiplicity 2 means it's squared. Here I have 2, So that'll be x minus 2. Multiplicity is 1, so it just stops there. So there's my function. For the most part, it says degree 3. Well, if we multiplied this out, wouldn't we get x squared times x? So it does have degree 3. Now the end behavior says up on the left, down on the right. Well, remember, up on the left, down on the right means that tells me it's odd and negative. Well, we're already odd because we know the degree is 3. Now we just need to be negative. We can just put a negative in front of it. All right? Or this one at the bottom, same idea. A little more work on this one. Oh, no, I take that back. Oh, no, that's the same one I have up there. I'm sorry, I repeated the same problem. Yeah, don't worry about that. That should have been left off of it. All right, that is 2.2.